In question number 16, the electric field at origin is along positive x-axis. The electric field is along positive x-axis, so we can write E I cap plus the cutting axis points E, B, C and D are given, at which point the potential is minimum. We want to find at which point potential is minimum. Here potential can be found by E dot dr. So potential at E will be electric field EI dot, the position vector of point A is I cap, AI cap, but potential is minus E dot dr, so there will be negative sign over here, so VA will be minus EA. Potential at B can be written as minus EI cap dot A J cap, so this will be 0. Same way potential at D can be written as minus of EI cap dot minus of A J cap, so potential at D will be 0. Potential at C can be written as minus of E I cap and position vector of C will be minus A I cap, so this will give us potential at C is equals to EA. Out of this 4 value, the potential at A is negative, so potential at A is minimum. So option 1 is correct option. In question number 17, the electric potential at point x00 is given as 1000 by x plus 1500 by x square plus 500 by x cube. We want to find the electric field at x is equals to 1 meter. The electric field from potential can be found by using partial differentiation. So E is equals to del V by del x I cap minus del V by del x j cap minus del V by del z k cap. Here y and z components are 0, so electric field will only be directed along x-axis. So differentiating this potential with respect to x, take 500 common, but minus this will be del by del x of 2 into 10 power minus 1 plus 3 into x power minus 2 plus 1 into x power minus 3. So electric field will be 500, differentiation of x power minus 1 will be minus 2 by x square, this will be minus 6 by x cube, this will be minus 3 by x power 4. Put the value of x as 1, the electric field will be minus 500 into minus 11. So electric field will be 5500 volt per meter directed along positive x-axis. So option 2 is correct option. In question number 18, it is given that an electric dipole is along uniform electric field. So initially it was along the electric field, now it is deflected by 60 degree. So the position of dipole will be making an angle 60 degree with electric field. In this case, the work done by an agent is 2 into 10 power minus 19 joule. We want to find the work done by an agent if it is deflected by 30 degree further. To deflect it by 30 degree further, it will become perpendicular to the electric field. Now, work done can be written as change in potential energy. So work done will be final potential energy minus initial potential energy. The potential energy of a dipole can be written as minus of Pe cos theta. So work done will be minus of Pe cos theta 2 plus Pe cos theta 1. Here initially the dipole was located along the electric field, so theta 1 was 0, and to rotate it by 60 degree, the work done given is 2 into 10 power minus 19 joule. So W1 is equals to minus Pe cos 60 degree plus Pe cos 0 degree. Here Pe minus Pe by 2. So 2 into 10 power minus 19 is equals to Pe by 2. Now, in the second case, initially the dipole was located at 60 degree and we want to rotate it by 30 degree. So final position will be making an angle 90 degree with electric field. Again, we can find the work done using change in potential concept. So W2 will be Pe cos theta 1 minus Pe cos theta 2. In second case, finally it is perpendicular to the electric field, so theta 1 will be 90 degree. So Pe cos 90 degree minus initially it was located at 60 degree, so Pe cos 60 degree. So W2 is equals to 0 minus Pe by 2, but Pe by 2 is 2 into 10 power minus 19 joule. So option 2 is correct option. In question number 19, three charges are located at the vertices of an equilateral triangle of side L. These charges are plus Q, and minus 2Q. We want to find the net dipole moment of the system. Here, this minus 2Q charge can be written as minus Q and minus Q. So, this two will form a dipole and this two will also form a dipole. The direction of dipole moment is from negative charge to positive charge. So dipole moment P1 will be in this direction and dipole moment P2 will be in this direction. The magnitude of P1 and P2 will be same as the charge and distance between them is same. So magnitude of P1 is equals to P2 is equals to QL. The angle between them will be 60 degree. Now as the magnitude of both the dipole moments is same, the resultant dipole moment P net can be given by 2P cos theta by 2. So 2P is Q into L and cos 60 by 2. So 2QL cos 60 by 2 will be cos 30 and value of cos 30 is root 3 by 2. So net dipole moment magnitude will be root 3 QL and the dipole moment will be directed along the angle bisector of these two dipoles. So that will be along the perpendicular bisector of QQ line. So option 1 is correct option. In question number 20, an electric dipole moment P is placed normal to the lines of electric field. Let's say this is dipole P. Initially, it is normal to the electric field. We want to find the work done in deflecting it through an angle of 180 degree. So after deflecting it by 180 degree, the direction will be exactly opposite direction. The work done is equals to change in potential energy, that is final potential energy minus initial potential energy. So work done will be minus of PE. Initially it was located at an angle 90. After rotating 180 degree, the angle with electric field will be 270 degree. So PE cos 270 degree plus PE initial angle was 90 degree. So work done will be both cos 70 and cos 90 value are 0. So work done will be 0. So option 4 is correct option. In question number 21, two equally charged identical spheres A and B repel each other with force F. Let's say charge on both of them is Q and distance between them is X. The force of repulsion between A and B will be F is equals to kq square divided by x square. Now another identical uncharged sphere C is touched to A and then placed midway between A and B. This uncharged sphere is touched to A. In this case, the total charge of the system will be constant, and as both the spheres are identical, the charge will be distributed equally. So after that, the charge on A will be Q by 2, charge on B will be Q, and the third sphere C is placed midway between them, and it will also have charge Q by 2. So this distance will be x by 2 and this distance will also be x by 2. We want to find the net force on C. Here forces acting on C will be due to A and B. Between A and C, the force will be repulsive force, so direction of force will be this, due to A. Between B and C, there will also be repulsive force, so direction of force due to B will be in this direction. So net force will be magnitude of FB minus FA. Magnitude of force A, FA will be K charge Q1 Q2 will be Q square by 4 divided by x by 2 whole square, that will be kq square by x square. Now force due to sphere B will be kq square by 2 divided by x square by 4. So this will give us 2kq square by x square. So F net will be FB minus FA, as magnitude of FB is more, that will be kq square by x square, but kq square by x square is F. So F net will be equal to F and it will be towards A. So option 1 is correct option. In question number 22, three charges plus Q minus Q and plus Q are located at points P, Q and R respectively at the vertices of an equilateral triangle of side R. Given F is equals to 1 upon 4 pi epsilon naught Q square by R square. We want to find the net force on P. The force on P will be due to Q and R. Force between Q and P will be attractive, as this is negative charge and this is positive charge. So direction of force will be in this direction. And force between these two P and R will be repulsive, as they both are positively charged, so direction will be away from the R. Let's say this force is F1 and this force is F2. Magnitude of F1 and F2 will be same, as magnitude of charges is same and distance is also same. So F1 is equals to F2 is equals to 1 upon 4 pi epsilon naught q square upon r square, but it is given as F in the question. The angle between these two forces will be 120 degree. As this angle is 60, this angle is 60, and this is the exterior angle, so this angle will be 120 degree. The magnitude of both the forces is same and angle between them is 120 degree, so the resultant will also have same magnitude. So F net will be equal to F, and it will be directed along the angle bisecting line. So this will be the direction of F net. This direction is given of positive x-axis. So F net is along negative x-axis. So option 2 is correct option. In question number 23, the potential distance graph is given. We want to find the electric field at r is equals to 1 meter, r is equals to 6 meter, and r is equals to 9 meter. This point will be 1 meter, this point will be 6 meter, and this point will be 9 meter. Electric field can be written as minus del V by del R. So electric field from the graph can be written as minus of slope. So slope at 1 meter can be written as 10 divided by 2, that will be minus 5 volt, as this is constant slope. Electric field at r is equals to 6 can be written as minus of slope. At 6 there is horizontal line, so slope will be 0. So electric field at r is equals to 6 is 0. Electric field at r is equals to 9 meter is minus of slope. Here, as this line is obtuse, is making obtuse angle with positive x-axis, the slope will be negative and the value of slope will be 10 divided by 2. So minus 5 is equals to plus 5 volt. So at r is equals to 1, potential is minus 5 volt. At r is equals to 6, potential is 0 volt. And at r is equals to 9, potential is plus 5 volt. So option 2 is correct option. In question number 24, the point charges plus 1 coulomb and minus 1 coulomb are placed at the vertices A, B and C of an equilateral triangle of side 1 meter. We want to find the force acting on charge at A. Here force will be due to charges plus 1 coulomb and minus 1 coulomb. The direction of force due to this 2 will be repulsive, so away from B. Let's say this is force F1. Force between A and C will be attractive, as this is positive and this is negative charge. So direction of force at A due to C will be towards C. Let's say that's it, F2. The magnitude of F1 and F2 will be same, as the magnitude of charged particle is same and distance between them is also same. So F1 is equals to F2 is equals to K 10 power minus 12 into 10 power here the charges are in coulomb only, not in microcoulomb. So force will be K into 1 divided by distance square, that is 1 square. So F1 is equals to F2 will be 9 into 10 power 9 Newton. The direction of force will be along the angle bisecting line, and angle between F1 and F2 is 120 degree. So the resultant F net will also have same magnitude of F1 and F2, that is 9 into 10 power 9 Newton. Now we want to find the electric field at A. Electric field at A can be written as E is equals to F by Q. The net force is 9 into 10 power 9 and Q is the charge on point A, that is 1 coulomb. So electric field will be 9 into 10 power 9 Newton per coulomb. So both the statements are correct. So option 4 is correct option. In question number 25, n charges Q, 4Q, 3, 9Q, 16Q, etc. are placed at distance of 1 meter, 2 meter, 3 meter, 4 meter from the origin point O on the same straight line. We want to find the electric field intensity at x is equals to 0. Here the nature of all the charges is same, so electric field due to all of them will be directly added. The electric field at x is equals to 0 will be kq divided by 1 square plus k4q divided by 2 square plus k9q divided by 3 square, and so on n times, n terms. Here it will be kq by 1, this 4 and 4 will get cancelled out, this 9 and 9 will get cancelled out, so kq plus kq n times. So electric field will be n q, and k can be written as 1 upon 4 pi epsilon naught. So option 4 is correct option. In question number 26, a block having mass m and charge q is resting on a frictionless plane at a distance L from the wall. The electric field E is switched on in this direction. The collision of the block with wall is perfectly elastic. That means there is no loss of kinetic energy. If this block hits the wall with speed u, then it will again bounce back with same speed u. We want to find the time taken by the block to return to the initial position. Let's say this is position 1 and this is position 2. Due to electric field, the force on this block will act in the same direction as the electric field, as the charge on block is positive. So it will start accelerating in this direction. After collision, it will again move in the opposite direction. While moving in the opposite direction, the electric field and motion are in opposite direction, so force will be retarding force. Here, due to elastic collision, kinetic energy is not lost, so time taken by this block to move from position 1 to 2 will be same as the time taken by to move from position 2 to 1. Let's say time taken by this block to move from 1 to 2 is t. So total time will be 2t. The force will be constant, so it will move the direction of L with constant acceleration. The force acting will be EQ is equals to MA. So acceleration will be EQ by M. So time taken by it starting from rest to move distance of L will be, using the second equation of motion, L is equals to ut plus half at square. Here u will be 0. Half a time taken is t. So t square. From this we can write t is equals to under root 2L by E. So total time taken will be 2t, that will be 2 under root 2L by E. But acceleration is EQ by M. So total time taken will be 2 under root 2ml divided by EQ. So option 3 is correct option. In question number 27, the electrostatic potential at any point xyz is given by 4x cube. That means the potential is independent of y component. So electric field along y and along z will be 0. Electric field along x-axis can be given as minus del v by del x I cap. So minus del by del x of 4x cube. So it is 4x square. So electric field will be minus 8x I cap. So option 2 is correct option. In question number 28, the electric field E is expressed as 2I plus 3J. We want to find the potential difference VA minus VB between 2 points whose position vectors are given as RA is equals to I plus 2J and RB is equals to 2I plus J plus 3K. Here VA minus VB can be written as integration of E dot dr from RE to RB. Integrating separately for I component, J component and K component, we can write VA minus VB is equals to 2 dot dx from 1 to 2 plus 3 dot dy from 2 to 1 and z component is 0, so plus 3y limits from 2 to 1. So this will be 2 into 2 minus 1 plus 3 into 1 minus 2. So 2 minus 3, that will give us the answer minus 1 volt. So option 1 is correct option. In question number 29, it is given that 2 point charges minus Q and plus Q are located at point 0,0A and 0,0 minus A. Let's say this is the z-axis, this is origin, so total distance this will be 2A. We want to find the electric potential at point 0,0Z given that Z is greater than A. So that point is, let's say P, this distance will be Z. Here potential at P will be due to minus Q and plus Q charges. So potential at P due to minus Q charge can be written as minus of KQ, as this charge is negative, divided by distance. This is Z and this is A, so distance will be Z plus A, plus potential due to this plus Q charge will be KQ divided by this total distance is Z minus A, so Z minus A. So VP can be written as KQ into 1 divided by Z minus A minus 1 divided by Z plus A. So VP will be KQ Z plus A minus Z plus A divided by Z square minus E square. So VP will be 2KQ divided by Z square minus E square. But VK can be written as 1 upon 4 pi epsilon naught. So it will be 2AQ divided by 4 pi epsilon naught into Z square minus E square. So option 3 is correct option. In question number 30, it is given that two charges of equal magnitude and opposite sign, that is minus q and plus q, are separated by small distance 2a. We want to find the electric field intensity at a point on a perpendicular bisector. Let's say this is perpendicular bisector and the point is located at distance r from the midpoint. This is the equatorial line, and electric field at equatorial line can be given as pk divided by r cube for r greater than, very greater than a, and it is given in the question, then r is very large distance. So as these two charges form a dipole, the dipole moment can be written as 2a q, and k can be written as 1 upon 4 pi epsilon naught r cube. So option 2 is correct option.